Hi, Chris Kuzmal here. Last time we seemed to have cheated in writing the method called legal that detects whether or not an argument called S is actually a legal logical sentence. And the way we cheated was we assumed someone else would write the hard parts, the method called simple and the method called complex. And then we cheated even more by making legal incorrect in a sense by writing the stub method. The stub method is one which runs, but it doesn't actually do what it's supposed to do. But that helps you move forward in the implementation process. Implementation helps you forward in sort of making the thing work. And so now we're ready to actually write simple correctly. So let's review what a simple logical sentence is. A simple logical sentence is a proposition constant. That is all. Okay, and here's some examples. P, Q, and then technically this too is a proposition constant. But we virtually never use proposition constants with more than one character. So each one of these lines, it could be a proposition constant as defined in the logic text, but we're going to constrain ourselves to just logical sentences that are of length 1. In other words, one of the members of the alphabet. And so one of these, A, B, C, all through Y. Oh, I've actually forgot to put a Z there. That's a little interesting bug that can come up later on. In any case, all we have to do is return alphabet.contains. There's a method, an automatic method that Java already has for us that tells us whether or not this string called alphabet, which is this long string, contains the string represented by this variable S. Okay, and we didn't write that. We've been using S before, so hopefully you understand from context what's going on there. And so that's pretty much all we have to do is detect whether or not a string is contained in the alphabet. And so the full code for simple starts off with those scary public static Boolean bit. We already talked about that. We already defined that first line of code before. We create the variable alphabet, which you'll notice I left out the Z in. It's going to come back and bite us someday. And then I've put in this a little bit scary looking piece of code, but let's break it down because this is something a logic student should be able to understand. If this exclamation point corresponds to negation. So in formal logic, we normally use a tilde. In Java, they use an exclamation point. And this double equal sign sort of corresponds to a biconditional. If the length of S is 1, then if it's not 1, then we return false. Okay, so that's the first step. If, in other words, we get past that line of code only if S's length is 1. And if alphabet, the thing up here, contains S, then sure enough, it's going to be one of those single characters. And that's what we return, alphabet.contains S. Guess what? We're done. This is the full code for simple. We have solved half of the problem. We have to write complex down the road, but we have written simple. And so when we move forward, we're going to learn about the substring method and how to do complex.